So I'm going to teach you about ions. I'm going to pull up a periodic table. So if I have Na plus, if I have Na plus, what does that mean?
Plus one ion.
Yeah, so does that mean I'm like missing an electron? Do I add a proton? What does that mean?
Usually metals lose like a proton or a neutron to stabilize when they gain an ion.
Okay, so really quickly, your proton count, right? The 11, right? The number of protons you have is like a characteristic of the element. It's never going to change. The only thing that changes to like make something like a cation or an anion is you lose an electron. Like in general, right? Like your proton, like not your protons, but an element's protons never, like go away. It's kind of like it's a characteristic of them. So, for example, Na plus wouldn't be gaining a proton; it would be losing an electron. So, if it becomes a proton, if it becomes an anion, right? So, anion means, if it becomes a cation, that means you're gaining a electron, not a proton. Does that make sense?
Okay.
Exactly what you said, but it's not an ion until you gain this electron or lose an electron.
Oh.
So an anion gaining an electron, right? So proton count stays the same. Does that make sense? Because if I go to the periodic table,
so
this number on top, the atomic number, tells you how many protons there are. So if you like take away protons, then it's not going to be one anymore. It's going to be 0, and there is no 0. So
just be nothing.
Yeah, but you don't take away protons. You add or subtract electrons. So, like I said before, the number of protons you have, the atomic number, this little number here, is like the defining characteristic of an element. So let's do some practice. So based on what I just told you, okay, so like I said, Na plus, what does that mean? When I say plus, what is it losing or gaining?
It's losing an electron and gaining an ion.
So there's no such thing as gaining an ion. It just becomes an ion from losing an electron, okay? So it loses an electron. So if Na loses an electron, what other neutral element has the same, so Na, like neutral, has how many electrons? So say I have Na, right? And it has, actually, let's undo this. So I have Na, and along with Na, I have, that's an arrow. Oh my god, this is really difficult already. It's okay. Can you delete the circle? I'm just gonna draw. Okay. Thanks. Okay. You're gonna have 11 protons, right? So that's 11 plus. Neutral. Okay. Let's just text. Neutral equals 0 charge, right? Right? Neutral means 0. So if I have 11 plus, to get 0, what do I have to have?
Minus 11?
Yeah, 11 minus. And minus means electrons, right? So to balance out, so neutral sodium has 11 protons and 11 electrons because a neutral element means the charge is 0. The overall charge, the whole entire atom has a charge of 0. Does that make sense? So let's do a practice one. Let's say I have sulfur. Let me get my periodic table out. Okay, I have sulfur. Okay, so that is number That is number 16 on the periodic table, okay?
Mm-hmm.
Neutral sulfur, there's no charge. It's not an anion. How many protons do I have?
16.
Good. How many electrons do I have?
16.
Good job. Yes. So you get the idea, right?
Mm-hmm.
Good. Okay. So just remember that because that's kind of important. So if I have sodium 11, right, and I'm saying I'm losing an electron, right? What other element on this periodic table has the same number of electrons as the sodium ion?
Sodium ion.
So if you know it has 11 electrons as a neutral element, and I'm taking one electron away. So how many do I have?
10.
Good. So what other element has 10 electrons?
Neon.
Good. So based on that, can you figure out how to write the electron configuration? So we said that sodium has the sodium cation ion has the same number of electrons as neon. So based on that, how would you write the abbreviated thing?
Neon +1.
Just neon. Any.
No,
It's literally just that.
it's just neon.
Just neon.
So basically, Na+11 is neon.
Yeah, so can you write neon's orbital for me? Like full out. Full. So this is the abbreviated. Can you write it out for me for like the full thing, like with the s orbital and the p orbital?
That's the. I forgot the columns.
Okay.
So like the columns.
I'm gonna
like
put something.
2p3s. I forgot the columns.
Okay. So this right here. Oh, can you see my screen? The periodic table.
Yep.
Okay. Right here, this block. This is 1s. Right here.
So 2s.
2s, 3s, 4s.
Okay.
2p, 3p,
so
4p. Neon is the electron configuration for Na+.
Oh.
Like that is the abbreviated one. I want you to write like the whole entire one. So if I were to do, for example, nitrogen, not abbreviated, I would have 1s2, 2s2, 2p3. Right? That's not abbreviated.
So 1s2.
Good.
2s.
So 2s, you want to fill this whole orbital, right?
Yep, 2s2.
Good. And then you want to get to neon. So how do you get to neon?
Is it the P block?
It is the P block. Good job.
Right. So 2p.
Good job. Like really, really good job. Okay. So based on that, can you figure out chlorine minus without me helping you? So I'll go back to the periodic table right here for you. So this is chlorine. And do the full one and do the abbreviated one.
So -1 ion.
So what does that mean?
Gain 1 electron.
Good job.
So that's argon. So that's 2s. 1s2, 2s2, 2p6, 2s2, 3p6.
Okay, good. One thing though, I'm just gonna do this so I can see it better. You repeated something.
Oh, 2s2.
Yeah. So what does that 2 need to be changed to?
2s3.
But
Oh, yes. No, 3s2.
Good job. Good job. Okay, we're gonna do harder ones now. Okay. And also, do you know that like they like this, like the element wants to get to Na+. Do you know that? Do you know why?
No.
Okay. So, remember how earlier you told me that noble gases were really stable, right?
Mm-hmm.
So if I lose an electron, I'm essentially neon, like you said, right?
Mm-hmm.
And that's really stable. So chloron minus and like chloride and sodium plus. So they want to get the noble gases. So losing electrons means you have a full orbital. So because the noble gases, their orbital is completely full. They're very stable. Taking away electron or gaining electron, they don't want it. They like the way they are. If I lose an electron, I'm becoming neon essentially, right? Neon's really stable. It's like perfect, kind of like comfortable, if you want to think of it that way. And so that's why sodium actually likes becoming an ion. And chlorine likes becoming chloride. Let's think of helium. Helium, it's only a 1s2 orbital, right?
Mm-hmm.
So that means this orbital is full, right?
Mm-hmm.
There's 2 electrons. So if I think about it, like by drawing, the arrow method, right?
Yep.
I have one up arrow and one down arrow, right?
Mm-hmm.
See how this orbital is completely filled? So that's why. So if I were to draw 118, it would look exactly like that, just a lot bigger. It's so reactive because there's so many. It's such a large molecule. It's such a large atom that has like no control over its electrons because it's so far from the nucleus. Because the nucleus has the positive ion or positive proton, and the electron is being attracted. But if I keep getting farther and farther, right, this electron here is not going to be very attracted to the proton in the center. So because it's so big, it's so reactive because this electron is going to like go away because the nucleus has basically no control over it. Does that make sense?
Mm-hmm.
Okay, let's do calcium 2+.
Calcium. So krypton.
Okay. Calcium 1. So krypton is 36, right?
Mm-hmm.
So krypton has 36 protons, right? But calcium only has 20 protons. So I can't get rid of the number of protons. So the one you want to find is not the one with more protons, but the one with less protons. Because krypton also has 36 electrons, but if you're taking away 2 electrons from calcium, you're making, how many electrons do you have?
18.
Yeah, so krypton though has 36.
Oh, argon.
Yeah, good
again.
job. So, okay. So technically writing it like this is not the best way to write it because you're not really showing anything, right? You're just saying, oh, it's exactly like neon, right?
Mm-hmm.
So what you really want to do is you want to go to the one before, the noble gas before argon, and do the electron configuration of argon from that noble gas.
From neon?
Yeah, so do it from neon. So it's isoelectronic with argon. So you want to go to neon and go all the way to argon, doing the sp2, sp3 thing. So you would do, not curly brace, any, okay? Sorry, any, and then you would do 3s2 because any, and then you're in the 3 orbital, 3s2 block, and then you would go 3p6 to get to argon.
Uh-huh.
So 3p6, and then that would be calcium 2+.
Yep.
So it's essentially just this,
Mm-hmm.
but scientists said that this doesn't tell you anything. So we have to write this.